Write and execute word count program. Here we shall mention step by step that how to write and how to execute our word count program. So to write a MapReduce program like our word count program, we must be using some IDE. So we'll be using say Eclipse IDE. In Eclipse, create new Java project, create a package if it is necessary because it is optional, and create the respective classes. We should attach Hadoop jars to use out Java program as MapReduce task, and all the jars available in these 4 locations or paths are to be included in our respective newly created project. So after importing the jars, write mapper and reducer class and the main function and export the project as a jar file. So we will be writing the code for the mapper and the reducer class, and obviously the main function will be there, and there we will be converting this project in the form of jar. In the terminal, start the Hadoop using this. So this is the command with the help of which we shall be running our Hadoop on our system. Run the jar file, and the syntax is Hadoop jar path, then the class name, and then arguments. So if the class name is having some package, then we shall be writing package.classname. So let us go for one practical demonstration for the easy understanding of this concept. In this video, I am going to show you how to configure and run the word count program in our MapReduce environment, and we shall follow step by step to show you that what are the different steps with the help of which we can run this word count program in our MapReduce. We'll be having our code in Eclipse. We'll be running the Hadoop at first. So at first we are going to initiate the Hadoop. We should run Hadoop at first because in the Hadoop environment only we'll be going for this program execution. So to initialize Hadoop, we are going to type, that is a $Hadoop _ install, all in capital letters, /sbin /start -all.sh. So this is the shell program we are supposed to execute to initiate the Hadoop environment. The Hadoop software will be running on our system, and then we shall go to the browser to check whether this Hadoop is working there or not. So here you can find the Hadoop is running. The Hadoop is initiating. Now we have got the $prompt. So the Hadoop is running successfully. We are going for JPS to see that what are the different processes running. So data node, node manager, name node, secondary name node. So all these processes are running. So Hadoop is running perfectly okay. We are going for the browser now. So going for the browser, we will be typing localhost : let me initialize it. Yes, we will be typing localhost : 570. So 50070 / and you shall give / and then you shall press enter. You see this Hadoop GUI is now effective. We are getting all the details about the name nodes. Now we'll be clicking on the utilities and browse the file system to see what are the different file systems we are having under this Hadoop root. So these are the file systems. We shall go for Hadoop My Files. You can click on that, and these are the respective programs are there, files are there. We'll be working on this sample _ file.txt, sample S capital, file F capital. So sample _ file.txt. So this is the sample file which is containing some strings are there. We are supposed to count the number of words, the frequency of occurrence of these words in this particular sample _ file.txt. So let me copy. Let me go for the content. Let me show you the content. So HDFS DFS -cat / Hadoop My Files. So I can type sample _ file.txt. Otherwise I can use the wildcard character star here, so that only this particular file is there, having got the name sample _ file.txt. So instead of typing the full file name, I'm just giving a star as a wildcard character. This is the corresponding text we are having. So this is the corresponding text we are having, and this particular text we are going to count the number of words there. So this is the text content. You can find that. This is the text content. Now we are going to make one directory. We are going to make one directory, and the directory name, we're going to create this directory directly at the root of the Hadoop. So sample input, we're giving the directory name as sample input. So you can find that HDFS DFS minus mkdir sample slash sample unit in sample unit input. We are having the respective folder name, and you know that slash means it will be created under this root of the Hadoop file system. So the folder has got created. Now we shall copy this sample from this Hadoop my files. We'll be copying this one. You see the folder will be shown here if I go for the refresh. So first time it is not coming. So sample input, this folder is a blank folder. You can find that there is no file or directory, subdirectories are there. So under this sample input. So from the Hadoop my files, we'll be doing the copy of this sample underscore file.txt into this sample input folder. So we are going to issue the command that is HDFS DFS minus CP. We'll be going for this minus CP here, and then slash Hadoop my files. There is a source path. Slash means the Hadoop root. So Hadoop my file slash sample star. We can go for sample star here. So sample star, and the target will be under root sample input, I capital sample input. So to this particular folder, this sample underscore file.txt file is getting copied. So this is the source path with the file name, and this is the target path. So pressing enter, and the file has got copied. I can move to the browser. We shall go for the sample input. You can find that the sample underscore file.txt, the file has got copied there. So there is 159 byte file, 159 byte. Okay, now we shall go for the Eclipse. So this is a Hadoop demo. We are having the SRC folder there, but there is some errors are there because it requires some jar files. So let me include jar files here, and we'll be importing these jars. We'll be including these jars from 4 different folders. So we'll be following one by one. So going for the right click on this project name, we're going for the right click, then we shall go for this build path and configure build path. Then we shall click on the add external jars. You see, we're having only this GRE system library JDK 1.8.0 underscore 181. So this library is there only. We're going for add external jars. So at first we're going for Hadoop share. We're going for the Hadoop folder at first. So there is a home. So there is a big data home here. So we'll be going for Hadoop. Then you shall go for the share. Then you shall go for Hadoop, and then common. So we are going to import these 3 jar files there. So from the 4 paths, we are going to import jars. So this is path number 1, that is slash Hadoop slash share slash Hadoop slash common. Now next one, going for the second one, we'll be going for now. There is a common lib. So we have gone for this Hadoop and then common, then lib. So multiple jars are there. We'll be going for the that is a Control A, select all, and then OK. So second path we have done. The third path will be our, there is a MapReduce, Hadoop MapReduce. So here we are having 9 jar files are there I can find. So I'm going for adding this external jars. The last one will be slash Hadoop slash MapReduce slash lib. Under this lib we are having multiple jars. So I'm going for Control A, that is a select all, and clicking on OK. So all the jar files have got imported here. So apply and close. You can find that the error symbol, the error marker has gone out. So now we are having this package is the default package under SRC. We are having this my word count.java. So this is a program we are having. Just executing this one, you can find that this is our code. So our class name is my word count, and under this very class we are having multiple inner classes. One is the WC mapper. So my class name is this one. So WC mapper, and then we are having main function, and also we are having WC reducer. So WC mapper, WC reducer. So 2 inner classes we are having, and the main function is there. So this WC mapper is extending this mapper. which is having this long writable, that is the value, text is the key, so that will be taken as input, and it will produce output as text as the key and long writable as output. So it is showing the key value pair here. So long writable is the value and text is the key. So that is our WC mapper, which is extending mapper, and here we have defined some instance variable within this class, that is the WC mapper. WC stands for actually word count. So this is the map function. We are going for this override this map function. So long writable key and text value. So mapper long writable comma text comma long writable. So this is the respective method we are going for overriding, and this is our exceptions which will be thrown. We have mentioned that one. So the value which will be passed as input will be converted to string and put onto the string object line, and from this line we are using this tokenizer, string tokenizer. So tokenize is the respective object, and from this tokenize we will be going for hash mode tokens, and using the next token method we will be reading each and every token there, and that will be assigned onto the temp token, that is the string object. And then we are replacing all these characters, that is our opening third bracket, dot, we are having comma, question mark, colon, semicolon, closing third bracket. So all these things will be replaced by the null string there. You can find that they will be replaced all, and we are converting all of them. We are converting all the strings in the lowercase. So let us suppose there is one word is this. So this can be written in capital letters, small letters, or mixture of that, but they will be converted to lowercase letters. So whenever we are going to count this. So now this is our context.write token 1. Okay, so that is a WC reducer where you are overriding the method reduce. So text key and iterable long writable values. So we are having this sum is equal to 0. So long writable val, we are using the for each loop which will be working on values, and sum plus equal to val dot get, and then result dot set num sum here, and context dot write key comma result. So key and results, that is a key value pair, will be written in the context. So this is our main function. So this main function requires on configuration object. So configuration conf is equal to new configuration, and we require the command line input argument must be having, if it is less than 2, if the command line input argument count is less than 2, then one error will be printed and system will get terminated, because system.exit -1. So I require 2 inputs. The first one is the source and next one will be the target. So that's why we shall be taking the command line input arguments when you'll be running this code. So here we have created one job instance. We can give any name. So it is not like that only my job is allowed. You can give any name, and then we are going for job dot set jar by class. So my word count dot class. What is the my word count? So that is our class name. You can find that my word count is nothing but the class name. So that has been mentioned here. So my word count dot class. Okay. So to access the command line input argument, for the first argument we'll be using args0. For the second argument we'll be using args1. So that is the add input path will be the args0 and set output path will be the args1. So to access the input arguments, command line input arguments, we'll be using this args0 and args1. So there is a job.set mapper class, there is a WC mapper, and job.set reducer class, WC reducer, which you defined earlier as the inner class. So job.set output key class, that is a text dot class. So output key will be text and output value will be long writable dot class. So you see line number 66 and 67 we have mentioned what to be the key type and what to be the value type. We mentioned that one, line number 66 and line number 67. Now we are going to check whether the job is getting completed or not. So it will return wait for completion. This method will return a boolean. So success. So using this success, if the success is true, then we'll be having the exit value 0. If the success is false, then we'll be having the exit value 1. So in this way, this is our main function we have written. So we have imported, we have included all the jars. Now we are going to make, we shall go for this. So Hadoop, we shall go for the right click, Then we shall go for the export, and the jar file is there. It's okay. So jar, then I shall go for next. So this is a Hadoop demo. So how about, so now here we will be creating one output folder here. So I'm creating one output folder. Let it be mr jar files. So here the output will be dumped under the big data home path. So here this wordCount.jar, we have done it. We have just created the jar under mr jar files. So one warning is coming. I'm going for OK. So this jar has been exported to the respective folder there. So mr jar files, you see the wordCount.jar. If you double click here, you can find that we are having the class that is a my wordCount.class. We are having the inner classes there, wc mapper class and wc reducer class. We are having the sample.txt. So this is a jar we are having, all the classes are there. So there is a sample input is containing sample file.txt. So this path will be requiring. Now let us execute our program, run our program. So clearing this one using Control L. So Hadoop jar is the home path, the tilde slash mr jar files. So there is a folder where the jar file was saved. So I shall go for this mr jar files, then slash wordCount.jar. Then you shall go for my wordCount. There is a class name. If you have the package, then obviously the wordCount.jar is there. If you have the package, then obviously I should mention the package name also. But here this my wordCount.class is under the default package. So that's why we're going for my wordCount. There's a class name slash sample input. So there's a sample input from where the file will be taken, and then we shall go for the output folder. You see the output folder is not there. So you see there is no output folder, so it will be created. You see there is no output folder there. It will be created when this command will be executed. You see it is running perfectly okay. So now I think the output folder has got created. 168 bytes have got written onto the file. So output folder is not there. Let me go for refresh. You can find that the output folder has got created. If you click here, we are having two files there. One is the underscore success, and another one is the part -r -5 zeros. Okay. So the output is has been dumped on that part file. So we shall go for HDFS, then DFS -ls, then output, which is under the Hadoop root. So let me see that what are the file names. We have also seen that one in the GUI interface. So we're having two files. One is the part -r -5 zeros and underscore success. So part -r -5 zeros. So this is the main file here. So let us go for HDFS DFS -cat to see the file content. We shall go for slash output slash part. I can go for the wildcard character. So rest part will be taken. So if you see the content, you can find that it is showing that how many words are there, what are the distinct words, and there are the respective frequencies, how many times it has occurred. So as we converted all the words to the lowercase, so uppercase and lowercase distinguishing will not be done. They will not distinguish. So A has occurred for 1 times. You can find that say this file has occurred for 4 times. So respective word count has been done. So this what kind program actually we treat as a hello world program in our MapReduce. Okay, so we know that if this output folder exists, so next time the another program cannot get executed. So we should delete this output folder, because next time if we execute any other MapReduce program, so I shall go for this DFS and then minus rm minus r, so that is a recursive, all the folders and subfolders will get deleted, and we shall go for this slash output. So in this way we have shown you that how to run one MapReduce program in our Hadoop environment, and what are the different steps should be followed, and how to import the external jar files, and how to put the copy of the sample underscore file.txt onto a certain folder. There is a sample input, how to create the folder, everything we have done step by step to show you how to make the jar files, how to execute the code, how to see the output. We have shown you everything into details. I think now it is cleared up your conceptions. So thanks for watching this video.